All right, continuing with our similarity test review, we are on to question number 5. So it says triangle ABC is similar to triangle DEF. The area of ABC is 100 centimeters squared, and the area of DEF is 4 centimeters squared. If the perimeter of DEF is 6 centimeters, what is the perimeter of ABC? So we're given areas, and we got to work towards perimeter. Okay. Now we know that the area is a scaled or a squared scale factor compared to the scale factor of the perimeter. So if we check our areas, we can take 100 over 4 is our area scale or proportion in 2 dimensions. And if we want to bring that to 1 dimension to find the scaling for the perimeter, we simply need to take the square root of it. Okay? Comparatively, in our problem earlier, we squared our one-dimensional scale factor. This was 1D, and we squared it to get our, keep erasing that. We scaled that to get our 2D scale factor. Now in this case, we're given the 2D scale factor, so we must do the opposite. We must square root it to get the 1D scale factor. So the square root of 100 over 4. Now we can either reduce 100 over 4 to 25, and then the square root of 25 equals 5, and that's a scale factor of 5 over 1. So that is our 1D, one-dimensional scaling for things like perimeter and side lengths. You could also split our root, so we can take this root here, and we can say that the square root of 100 over square root of 4 is equal to 10 over 2 equals to 5 over 1. So our properties of square roots and exponents allows us to do that as well. But regardless, we come to and find our one-dimensional scale factor is 5 over 1. So 5 over 1 is the proportion that must equal the ratio of our bigger triangle, and we go back to our areas and we see that ABC is big compared to DEF, which would be smaller. So we must know that 5 over 1 is equal to ABC over DEF. Well, DEF, our perimeter is 6, and we're looking for ABC, which we can just call x. So 5 over 1 equals x over 6, and then we can solve this. So we clear our denominator of 6. We get 30 equals x, because 30 over 1 is just 30. So the perimeter of ABC must be 30. Now, another option we have here is since our one-dimensional scaling is 5 over 1, and we know that we're going from small to big, we can multiply by 5 over 1. And so we could have just done 6 times 5 equals 30, which you see is the math we end up doing anyways when we set up our proportion. Okay, here we're starting to look at the side splitter theorem, or triangle proportionality theorem, where if we know that segment DE is parallel to AB, one of these segments is parallel to our base, then the sides are divided proportionally. So let's see, DE equals 4 and AB equals 10. CD is x and DA is x plus 3. So we can set up a proportion. We know that 4 over 10 must be equal to x over x plus 3. And one of these things that is implied by this side splitter theorem or triangle proportionality theorem is that the two triangles CDE and the triangles CAB are similar. That's why this works. So if we have x compared to, this would be 2x plus 3, and then 4 compared to 10, we could set up our proportions and solve. But we also have this little proportion where we can just go directly to their parts. So like x compared to x plus 3 is proportional to 4 and 10. So we can just go directly there without having to split our triangles. Now we solve our proportions the same way we always do. We can multiply both sides by 10, clear our denominator. We get 4 equals 10x over x plus 3. We multiply both sides by x plus 3. And we distribute to both terms. We get 4x plus 12 equals 10x. We want all our x's together, so we subtract 4x from both sides. We get 12 equals 6x, and we divide by 6 and get x equals 2. Okay, so that is how we would find the value of x, and you could substitute that back in to find the side lengths if you wanted to. And if we actually do that, we would say that this side would be 2, this is 2 plus 3, which is 5, and we can check our proportion. 2 over 5 equals 4 over 10, which is true. So we confirm our answer here. Nice, quick, easy check. Okay. Problem number 7, same idea. They give us that this is a trapezoid, which by definition has a parallel base on the top and base on the bottom. You do not need to know that for the test. You will be given that it's parallel, or you'll be told that information, but this sample problem just chooses to provide you with that it's a trapezoid. Okay, so we have MR equals 9, MP equals 2, and PO equals 4. And our triangle proportionality theorem tells us that we are splitting proportionally. So this proportion of 2 over 4 is equal to the proportion of MT over TR. But we have a problem. We don't actually know what MT or TR are. But we do know the entire length of MR is 9. And we could figure out the entire length of MO by adding 2 plus 4 is 6. So instead, we can do that. Because in this problem, we are looking for length TR here, which is going to match with 4. And what we can say is that 4 over 6 is equal to TR, which we'll call x for now, over 9. So what we do is we use our given information to set up a proportion that we know to be true. And this goes back to that idea we talked about a moment ago with our similar triangles. And our triangle proportionality theorem allows us to just go to their little parts. Here we can multiply each side by 9, and we get 36 over 6 equals x. We could multiply both sides by 6, but 36 divided by 6 is just 6. So we get 6 is equal to x, which is the length of segment TR. So TR is equal to 6. And we could check this idea. If this is 6, that would mean that this is 3. Is 2 over 4 equal to 3 over 6? It certainly is. So that's a quick check. We could also check, does 4 over 6 equal 6 over 9? They are both equivalent to 2 over 3. So this also checks. So quick, easy ways to check our work. They're not very time consuming, but we do want to confirm that we're right. Okay, and here we're going to use the angle bisector theorem. So by the diagram, we know that this angle is congruent to this angle, which means that we have an angle bisector. And our angle bisector theorem tells us that this divides our triangle proportionally. So we can set up some proportions, one of which would be 10 compared to x is the same proportion of x plus 7 compared to 6. So we could say 10 over x equals x plus 7 over 6. Okay, so now we can multiply both sides by 6, and we are given 60 over x equals x plus 7. Here we're going to multiply both sides by x, and we get 60. We can distribute. So x times x is x squared. 7 times x is 7x. And so now we are actually dealing with the quadratic, which you're not really going to have to worry about for the test. But I will solve it out just to show you the process and give a little refresher. So one method that we have is we can set this to 0. So we subtract 60 from both sides, and we are left with 0 equals x squared plus 7x minus 60. And in solving a quadratic, we would want to look for what adds to 7 and multiplies to negative 60. Okay. Well, if we multiply to a negative and add to a positive, we must have a big positive number and a smaller negative number. So we're going to look for factors of 60 and negative 60. So we have negative 60 times 1, or 1 times negative 60. Sorry. We could do 60 times negative 1. We could do 30 times negative 2. We could do 20 times negative 3. But none of these are adding to 7 yet. We could do 15 times negative 4. That sums to 11. We could do 14 times negative 5. Could we do that? No, that would be equal to 70. That does not work. We could do 12 times negative 5. There we go. And 12 times negative 5 equals 7. So our factors could be 12 and negative 5. We could rewrite this then as x plus 12, x minus 5 equals 0. Now, if either of those are 0, the entire expression becomes 0. So we would end up with x equals negative 12 and x equals 5 as our solutions. And again, that's not on the test. Don't worry too much about that. If you've seen it, it's just a little bit of review. Your proportion would not result in a quadratic. Okay, and we don't want a negative side length for our triangle, right? How do you pick a solution? Well, this doesn't work. So we would say x must be 5, and we would quickly check our answer. So we could say if this is 5, this is 12, and we would want to confirm, does 10 over 5 equals 12 over 6? And it certainly does. Both of those are a proportion of 2 over 1. Again, there will not be a quadratic on the test. There will be a question about angle bisectors, so you'll have to know how to set up a proportion like this, but in the process of solving, you will not get a quadratic, okay? Alrighty. Okay, here we have 3 parallel lines cut by 2 transversals. We are given that UV is 8, so I mark my diagram. VW is x plus 1. YZ is 2x minus 3. And we are looking for the value of x. Where am I missing? So where's xy? xy is 9. All right, there we go. Okay, so now we have to set up a proportion. Our 3 parallel lines theorem cut by 2 transversals tells us that UV to VW is equivalent to the proportion of xy to yz. So we're going to say 8 over x plus 1 is equal to 9 over 2x minus 3. Multiply both sides by x plus 1. And we get 8 equals, distribute, 9x plus 9 over 2x minus 3. Multiply by 2x minus 3. And we distribute to both terms. We get 16 minus 24, 16x minus 24 equals 9x plus 9. So notice how this is similar to the last problem, but we don't get a quadratic. So that is what you can expect. You'll have to set up proportions such as this that involve x in multiple places, but you should not expect to end up with a quadratic. Here we're going to subtract 9x from both sides, and we can add 24 to both sides. So this would give me 7x is equal to 9 and 24 is 33, and x equals 33 over 7. Okay, and there are no common factors between 33 and 7, so we will leave it as such. Okay, our next example asks, what is the equation of the midsegment containing sides AC and BC in triangle ABC with A 0, 0, B negative 4, negative 2, and C 8, negative 8? So we want to model this situation. So A is 0, 0. We'll put some point A. B negative 4, negative 2. So that would actually be to the left of A if we want to visualize that on a grid. So I'll just put it somewhere over here. And C is at 8, negative 8. So somewhere over here. Okay. And it's nice to help us visualize, at least generally, where these points are, even though we don't need a perfect grid. Okay, so we want the equation of the midsegment connecting sides AC and BC. So that means we need the midsegment connecting this side and this side. So some midsegment here, right? So these two midpoints are going to be joined to form a midsegment. We can call these points M and N, but we don't have to. So we know a midsegment is the connection of the midpoints. M is a midpoint of AC, N is a midpoint of BC. So we'd want to calculate the midpoint of AC, and we can say that is equal to the x coordinates summed over 2 and the y coordinates summed over 2, which gives us 8 over 2 and negative 8 over 2, which gives us 4, negative 4. Okay, so that is the first coordinate of our midpoint. Then we want the second coordinate of our midpoint, so we can take midpoint of BC, which is N. That is equal to negative 4 plus 8 over 2, and negative 2 plus negative 8 over 2. We get 4 over 2 and negative 10 over 2, which is 2, negative 5. Okay. All right, so if we want the equation of the line that goes through MN, and truthfully, what we actually have is a line segment, but the problem is asking for the equation of this line that goes through MN. Okay, so that's what we're trying to find. So what we can do here is look for the slope between AC and BC. So we can say that the slope of MN is equal to the change in y, so negative 4 minus negative 5, our y coordinates, their difference, over the change in x, 4 minus 2. And be careful, make sure that if you choose negative 4 as your first value, you also choose 4 as your first value. You just need to be consistent with it. So negative 4 minus negative 5, that's like negative 4 plus 5, which is 1. 4 minus 2 is 2. So our slope is 1/2, and we just want this actual slope. Sometimes in problems we need the perpendicular slope, not here. We are just looking for the actual slope between MN. Okay, and then if we want to write the equation of the line, we usually like slope-intercept form. So we can pick either of these points, M or N, and substitute them in because we know that y equals 1/2 x plus b. And we want to figure out b. We can substitute in our coordinates, so 4 for x, negative 4 for y. We get negative 4 is equal to 1/2 of 4 plus b. 1/2 times 4, half of 4 is 2. We subtract 2 from both sides to isolate b. We get b equals negative 6. So our final equation is y equals 1/2 x minus 6. And now I can also check this to make sure we are correct because I used point M to find this, but it should also go through N. So if I plug in the values of N, such as negative 5 and 2, this equation should still hold true. So this is my quick check. So 1/2 of 2 is 1 minus 6, and that's supposed to equal negative 5. Well, 1 minus 6 is negative 5, so I'm able to quickly check my work and confirm that my equation looks good. So this is the equation of the line going through the midsegment MN. All right. Moving on, we have number 11. So this says, in exercises 1 and 2, find the value of x that makes triangle ABC similar to triangle RST. And we have triangles. And in number 1, it's pretty obvious that these triangles are not aligned properly, but you always have to be really careful. If you have a similarity statement, you want to look at the order of the letters, right? Order matters because A corresponds to R. So A corresponds to R. Let's see. B corresponds to S. And finally, C corresponds to T. Okay, and actually this is the same case in our other diagram, so I might as well mark it in there as well. So we said C corresponds to T. So C matches with T. We said B matches with S, and A matches with R. So you might be thinking in the first diagram, well, it's obvious to look for this. In the second diagram, it's trickier to notice that these triangles are actually backwards. We would have to reflect or somehow change one of them so that they actually align. So they're upside down in a sense. You have to be really, really careful when you have similarity statements that you don't assume that the triangles are already in proper order. Okay, now my strong recommendation is to redraw these triangles so that they match. So if T and C match, I'm going to put C right here. B and S match, I'm going to put B right here. And A and R match, I'm going to put A right here. So now it is easy for me to keep track because now in my new redrawn triangle, this and this match. Okay, and CA was 2x plus 3. CB was 2x. And BA was x minus 2. And if I'm looking for the value of x that makes these two triangles similar, I need to set up and solve a proportion. There's a number of ways to do this. You could compare any two sides and their ratios and you could solve it. I'm actually going to choose to do RS and TS compared to AB and CB. Because I see that there's 28.5, and if I can avoid doing math with a decimal, I'm going to. So I can say that 9 over x minus 2 should have to equal, let's see, 24 over 2x. And now I can algebraically solve by multiplying to clear the denominators. 9 times 2x is 18x. Multiply by x minus 2. These cancel. And we'll come over here. We get 18x equals 24x minus 48. Subtract 24x from both sides. We get minus 6x equals negative 48. Divide by negative 6. And x is equal to 8. Okay, so x would be equal to 8. We would have a proportion. I can check quickly. If I plug in 8 for my x, this side AB is 8 minus 2 is 6. This side CB is 2 times 8 is 16. And this side 2x plus 3 is 24 plus 3 equals 25. So I want to check, does 9 over 6 equal 24 over 8 equal 28 over 25? And the first two, why did I write 8? It should be 16. Okay, so 9 over 6 is equivalent to 3 halves. 24 over 16 is equivalent to 3 halves. And my math was incorrect for some reason. I wrote 25, but it is not 25. 2x plus 3, so 2 times 8 is 16, plus 3 is 19. So this is 28 over 19. So if I take 28.5 divided by 19, check in a calculator, I get 1.5, which is equivalent to 3 halves. So all these check. The value of x that makes these triangles similar is x equals 8. Okay, let's see if I can shift this over to make space for our second problem. Okay. Now, this is a problem that's a little tricky because these triangles are backwards. We need to be very mindful of the order of our similarity statement. When we have triangles that just exist in space, we cannot assume that they are aligned in any way. We have to clarify. So here I want A to match with R, so I'm going to put A over here. I need B to match with S, and I need C to match with T. So I'm redrawing my triangle so that the orientation matches, so that it is easy for me to see what matches with what. And BA is x plus 2. This is a C. BC is 7. And AC is 5. So I relabel my sides. And now it is much easier to set up and solve. So I could pick any two side lengths I like. I'm going to choose 20 and 5, so RT compared to AC, excuse me. And I will pick 44 compared to x plus 2, because those numbers look easiest to me. And I could say that x plus 2 over 44 is equal to 5 over 20. There are more proportions I can set up, but that's one option. I can multiply both sides by 20. And I get 20, making sure to distribute, 20x plus 40 all over 44 equals 5. Multiply by 44. 5 times 40 is 200. 5 times 4 is 20. So 20x plus 40 is 220. We subtract 40 from both sides. And I get 20x equals 180. And I divide 20. And I get x equals 9. Now, there's actually another method I could have done here. So if I looked back at, let's put this proportion over here, 5x plus 2 over 44 equals 5 over 20. Well, I can see that 5 and 20, I would have to multiply by 4 or divide by 4 to get from one to the other. So if I have 44, to multiply by 4 to get 44, or 44 divided by 4, excuse me, is 11. So that means that this x plus 2 has to equal 11, and for that to be true, x must equal 9. So that's another way to solve it. There are typically many ways to solve these. I like to go through the algebra to get some extra practice, but that is another way you could have done this. And then to check, I can plug in 9, so this x plus 11 would give, or x plus 9, sorry, would give me 11. So this is 11. 3x, 3 times 9 plus 1 is 28. And then I check my proportions. Does 44 over 11 equal 28 over 7 equal 20 over 5? The answer is yes. All of those are equivalent to 4 over 1. So we are good. And we come to the last problem in this review sheet. So it is a proof. It says, given that AC over DF is equal to AB over DE, prove that angle B is incongruent to angle E. Okay, so in my proof, I can start with my statements and reasons. So I can say that AC over DF is equal to AB over DE. Reason is given. And I want to mark my diagram. So AC over DF, so the proportion of this to this, is equivalent to AB to DE. So there's sort of this like weird similarity marking that I'm doing, just to sort of help me visualize what this problem is telling me. And then we're also given that angle A is congruent to angle D, given by the markings in the diagram. And because I can mark that as well, I see that I have a side angle side matching a side angle side. So I can say that triangle ABC is similar to triangle DFE. And the reason is side angle side similarity. And marking the diagram is really, really important here, because it actually highlights the mistake I just made, which is a very common mistake that could happen. AB corresponds to DE. So I actually need to change the order of my statement from DFE to DEF. These triangles are reflections of each other. They are not oriented the same way. So I need to make sure that my similarity statement is in the proper order. So marking my diagram allowed me to catch that mistake, because otherwise there's not enough information to know which direction these triangles are actually in. And then if the triangles are similar, well, then we can state that B is congruent to E. So angle B is congruent to angle E. I will accept definition of similar triangles. So that's the symbols for that. You could also say corresponding angles of similar triangles are congruent. This is an acronym you could choose to use. but definition of similar triangles is much easier. Okay, so that concludes the review packet. I hope you found this helpful, and thanks for watching.